Hello and welcome to another tutorial. We are going to continue our discussion on the methods in Java, and we said that usually we always follow the convention of camel case naming, and we said that methods have to have a unique signature, and the signature of the method defined as its name and its parameter types. The name of the parameters doesn't matter, only the type of the parameters and the order in which they appear as the parameters of the method that matters. Obviously the number of parameters matters, right? And then Java allows you to have the same method but with different parameter types. Or when we say same method, it means a method with the same name, with the same signature, right? And then different, not with the same signature, so methods with the same name but different parameters, which means the two methods, although they have the same name, they have different signatures, because the rule is that every method has to have a unique signature, and the return type, the modifiers, whether it's abstract or static, doesn't matter. Those are not considered part of the signature. The signature of the method is its name and the type of parameters, the number of parameters, and the order of parameters, the order in which the parameters appear, right? So overloading methods means you can have methods with the same name but different signatures, and because the names of this are the same, signatures are different. The only conclusion is that the type of parameters or the order of parameters or the number of parameters that the method accepts must be different, right? And this is called overloading methods. Java programming language supports overloading methods, and Java can distinguish between methods with different method signatures. So this terminology, method signature, pops up whenever you discuss method overloading or overloading methods. And remember, we said that constructors are just treated as a special method in a class. So if we can overload, and method overloading is a general concept, so we can also overload constructors, which means obviously constructors, all of them have to have the same name, which is the name of the class, but they can take different parameter types or different number of parameters or different order of parameters, and those are all valid overloads for the constructors. So this means that methods within a class can have the same name if they have different parameter lists or types or different number of parameters. There are some qualifications to this that will be discussed in the section titled Inheritance. So when we deal with inheritance, we will look at more details about this overloading. Suppose that you have a class that can use calligraphy to draw various types of data, strings, integers, and so on. And that contains a method for drawing each data type. It is cumbersome to use a new name for each method, for example. Now, obviously, if the number of things that you want to is limited, you can have different names, right? Draw a string, draw integer, draw float, and sometimes you have to do this. But if draw has the same functionality based on, basically the functionality changes based on the parameter that it receives, then these all methods, they can have the same name, but the type of parameters can be different. Instead of saying draw a string, we say draw that takes a string as a parameter or as argument, right? And then Java allows this because the name of the methods are all the same, they're all draw, but the type of parameters or the signature of the methods is different. Therefore, this is a valid overload, and Java has no problem compiling and running this kind of codes, right? In the Java programming language, you can use the same name for all the drawing methods but pass a different argument list to each method. Thus, the data drawing class might declare 4 methods named draw, each of which has a different parameter list. So we have draw, they all have the same access modifier public, they don't return anything, right? And then they take different parameters. And again, the signature of the method is just the name and the type of parameters. That's it. The return type doesn't matter. And these 4 methods, they have the same name but different signatures. So Java compiler has no problem compiling it, and at runtime, what happens is that basically at the JVM, based on, you call the same draw, the same name for the method that you're calling, but based on the argument that you pass, because Java is a statically typed language, so at runtime JVM knows the type of parameter that you pass to a method. It actually knows correctly which method to call, right? So that's a great advantage of method overloading. And That's the only way to allow this kind of behavior for a statically typed language. Now, other programming languages like Python, they're dynamically typed, so they don't actually have a compilation phase. So you don't specify the type of parameter. At runtime, the virtual machine checks the type and sees that if it's possible to use that type inside the body of the method, right? So, but for Java, which is a statically typed language, you have to specify the type at compile time, or basically every parameter of a method has to have a type. Then, if you want to distinguish what action happens based on the type of parameters, then it's easy to use method overloading. Overloading methods are differentiated by the number and the type of parameters or arguments passed into the method. In the code example, draw a string s and draw int I are distinct and unique methods. They have unique signatures of their own, right? Because they require different argument types. Remember, the signature of the method is the name and the type of parameters. You cannot declare more than one method with the same name and the same number and types of arguments because the compiler cannot tell them apart. So let me create a package here called methods. All right. And then let's call this class method overloading. Let's have a main method here. All right, so what do we want to do? Let's say I want to have a method. Let's call it public void say something, right? Or say hi. This is a typical example. We don't take any parameters. And because this is not an abstract method, we have to specify a body, even an empty body. So let's say sysout hi, right? And now let's have another method, say hi, but now the compiler obviously doesn't allow us to do this because these two methods have the same signature. The name is the same, the type of parameter is the same. It's no type, right? So we can pass a string as a name here. And then here we say hi, basically %s dot formatted name. So this is what we can do. This is a valid overload. So this is a valid overload. The signature of this method. So signature of this method is fully qualified name of the method. This is in this package the class name, right? And then basically the method name, say hi, and then underscore basically the parameter types, which is void, right? Same here. So for the signature of this method is a fully qualified name of the class. So remember, when we compile this, the compiler compiles the name of this class. The actual name of the type is the fully qualified name. So package, the class name, the method name, and then so actually two underscores signifies overload. And then let's actually put this down, or maybe put this up before the method. So whenever you want to specify that this method is overloaded, you after the name of the method you put two underscore and the type of parameters, because the type of parameters is part of the signature. So what is the type here? Obviously here we didn't have any parameters, so it's just underscore nothing. Say hi. The type of parameter is a Java string, right? L semicolon, because it's a Java object, java.lang string. All right. So this is the signature, the full signature of this method. Now we can have more overload. For example, we can say name first name, and then a string last name, and then a %s. So we say first name and then last name. All right. So here we pass a name, could be first name, could be last name, could be a combination of both. It doesn't matter. We just take it as one argument, and this is a valid overload. Okay, let me copy and paste this here too. So this is also a valid overload of the previous methods. And remember, overload, the key about overload is that the concept of method overloading applies when all methods are in the same scope. Right now all these three methods are in the same scope, the scope of the class, right? Later on we will see that when we look at the inheritance and method overloading. So there is another concept called method overloading. There is another concept, sorry, not method overloading, called method overriding. This is a different concept that applies when you have the same method signature but in two different classes, and one of them is a subclass of the other one. Then you don't overload the original method, you are overriding it. And then at runtime, when you call that, based on which class, which type you're calling that method on, the JVM knows which actual method to call. So have this in your mind. Method overriding is different from method overloading, and right now we're talking about overloading methods. And again, we said that the method overloading applies when all of the methods are in the same scope. Right now only 3 are in the same scope, which is the scope of this class. All right, so if you have 2 methods that are not in the same scope, you definitely are not overloading. So you might be overriding them if one of the methods is in a subclass, the other one is in a superclass, but overloading applies only when all the methods are in the same scope. All right, now these are valid. And then the signature of the second one, it takes 2 Java strings. Java strings are signified by L semicolon and the fully qualified name of the type, right? Remember, a string is not the name of the type. Java lang string is the name of the type. The name of the class definition is a string, but it's in a package called Java lang. And when the Java compiler compiles that class and creates a class file, the name of the type is the fully qualified name, which is java.lang.string. All right. So when we want to signify the overload in the signature of the method, basically we use underscore underscore and then a Java lang string. All right. Now there are a few questions that we want to answer. Question 1: does return type matter? Right. So let's see. If I take this method, which I already have declared, if I just type it here, we get a compilation error. And if you look at the compilation error, it says that duplicate method say hi in the type method overloading, right? It says that you're in the scope of this class, but you have a duplicate method definition, which means 2 methods that have exactly the same signature. So so the compilation, so Java C error when you have duplicate methods. Didn't I copy this? Let's copy this. Let's copy. Okay. So why is it that I cannot copy this? Let's see. All right, duplicate method say hi, which means the same signature, but it also says that you're in this particular type, which means in the same scope, right? So in the same scope, which is not allowed. So you can't have duplicate methods. Duplicate method means they have exactly the same signature. And what if one of the methods return an int, and then we say return 2? Is this allowed? The answer is no. Why? Because return types, apps access modifiers, they are not considered part of the signature, and the duplicate method error only applies for the signature. So Java C only checks the signature of the methods in the same scope. So again, if I hover in, it still gives me the same duplicate method error. So it doesn't care about the return type, right? It doesn't even care about, for example, the access modifier. It doesn't matter. It's not part of the signature. You cannot have duplicate methods based on the signature of the methods. All right. So this is not allowed. All right. So later on we will see some sort of polymorphism. For example, let's say you have a parameter type, a method that takes a parameter type, another method that takes a parameter type which is a subclass of the previous one, and then the question is that allowed or not? So if you recall, in the classes we had bicycle, so I'm going to make this public. All right, and then in the mountain bike we saw that this extends bicycle. So let's try to do this. Basically check model or check speed, and then bicycle we have the speed, and mountain bike we also have this. So all right, so we're going to return the let's also make them like the access modifiers don't matter. Let's pass in a bicycle, and then we're going to say that this method expects us to return an int. So let's say bicycle get so we don't have a get speed, but speed a public method, a public field. So I'm going to, actually this is not the best practice, so let's set apply. So public int get speed. The best practice is to have a getter instead of public fields. This is not the best practice, but for now I'm going to keep them like that. So we have this method. Right now it says that this method is private, you're not using it, you've never used this method, so there is no point of having method. So, and this is a compilation warning, but let's make it public so that we don't get this warning at the moment. So bicycle is a superclass of, and then now we can say get a speed. This is allowed. What if we say mountain bike? Is this allowed or not? And the answer is it's allowed. So we say that bicycle get s. Note that exactly the same code, even the same body, but the types are different. And remember, both types, bicycle and mountain types, are public types. So this class method overloading is another package, and we have access to these types. And then get a speed is a public method inside of each type, so we have access to them. And know that get a speed is defined in the bicycle. Mountain bike doesn't have its own get a speed. So although the types are different, and then we can have we can exactly have the same body at runtime. If your mountain bike has a different speed, or based on whether you're passing a bicycle or mountain bike, the body of the code can be different. Right now we're assuming the same body of code, that's fine. But what the point here is that you can overload based on the types of the parameters. That's one of the meaning, because these two methods have different signatures. Even though there is an inheritance relationship between these types, it's still a valid overload because the actual types are different. So Java compiler realizes that the bicycle type and mountain bike type are two separate types. They have their own class definition, even though every mountain bike is a bicycle, because of the inheritance relationship, but you can still overload based on different types, even though they're in a class hierarchy kind of relationship. So does return type matter? No, it's not part of the signature. It's not considered part of the signature. So therefore, it doesn't matter. You can do the duplicate method error doesn't apply to return type. Only the signature, which is the name plus the parameter. So can you overload based on subclass and superclass? And the answer is yes. They are different types and result in different method signatures. So this is a valid thing. So the final thing that I want to show you, let's have a quick look at the bytecode. So let's go into the methods and let's see if we can figure out the method signature for these overloaded methods. Let me go full screen, and then so we have the say hi. Remember, even if we didn't declare a constructor, the compiler has added a public no argument constructor. That's one of the requirements. So we have a say hi, another say hi, another say hi. But you see the arguments are different. So this say hi, the exact signature is this one, say hi with empty round brackets. The other one is say hi. So basically in the bytecode that right now we're seeing, the signature is this, say hi with a parameter that has a fully qualified name for its type, which is Java lang string. And again, in the source code you write a string. In the bytecode, the type is the fully qualified name, Java lang string. The third one, oh, by the way, here's the method descriptor. So this is also very important. Let me also copy this. So method descriptor is also a very basically important concept that describes what parameters the method takes and what is the return type. So the return type is based on method descriptor, but it's not part of the method signature. All right. So the second one has a method signature, method descriptor. Again, this third line of code is the method signature. This fourth line of code is the method descriptor. Descriptor is the name of the method, which is this constant in the constant pool. That's an advanced topic. Also the type of parameters, L Java lang string semicolon, and then the return type. So the return type is part of the description of the method. And the reason I'm bringing this up is that if you're familiar with Java native interface, how you call or bind a native method in Java to a C++ function, the descriptor is the important thing, right? You have to also specify what is the return type of the method in that case. So the last one, the method signature, is the name of the method. Let me copy this. So say hi, 2 parameters, Java lang string is the type of the first parameter, Java lang string is the name of the second, and then the method signature is that, again, the name of the method is in a constant pool of a class, and then the type of parameter Java lang L, Java lang string semicolon, that's one type. L Java lang string semicolon is another type, which is a string, and the return type is void. So I hope now you have an understanding of methods. The last comment before ending this is that other modifiers like static doesn't matter, so you can overload a static method with a non-static method. Again, a static, abstract, public, or even the return type, these are not considered part of the signature of the method. So the compiler only looks at the signature, which is the name of the method and the type of parameters. And again, the reason that only signature matters, because the whole idea of overloading is that the assumption is that all the methods are in the same scope, right? That's why these access modifiers don't matter, because if they're in the same scope, which means they're in the same class, if I make an object of this class and say that object dot say hi, the JVM doesn't know which method to call until it looks at the parameter types. Basically, JVM distinguishes these based on the signature of the method and the way you call it. All right. So I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one.